of the biodiversity in our neighborhood, the Oakwell Series seminars. We're really excited. This is something, very unique. We feel lucky as CBES, as part of the College of Liberal Arts and Sciences at Villanova, to have partnered with some great people from the Grow Oakwell movement for various initiatives in our efforts to preserve Oakwell. But one of the coolest ones, I think, has been this idea of really highlighting the biodiversity that we have here in the main line, which we know is fairly substantial. And as we've been learning from both the bio blitzes we've done at Villanova and over at Oakwell, it's continually amazing all of us in terms of the kinds of biodiversity that we have right here in our neighborhoods. And so really the purpose of this seminar series is to sort of make these connections between people in our neighborhood and in our broader community outside of Villanova, with some Villanova scientists who are experts in these areas. And I'll say too, many of the community members that I've interacted with as part of the Grow Oakwell movement are also amazing experts in biodiversity, including in herps and birds and all kinds of various organisms. So, we feel really lucky to be doing this. And just to orient you as to where we are so far in our seminar series. So we had Dr. Kel Weeder kicked it off with Who Doesn't Love Bats a few weeks ago. And then Dr. Aaron Bauer told us about the hidden herps of the main line. And he got to tell us some really cool things too about how to best preserve herps in our area and also how to improve habitat for them in our neighborhoods, which I've been thinking a lot about recently with respect to Villanova's campus. And then my seminar last week was a technological breakdown, which we really apologize for, but we just had some issues with the Zoom setup and things like that. And so we're going to push my seminar, which is about the forest understory, to September 4th. So it'll be after Dr. Adam Langley's. And what we are lucky to, after today's seminar, and I'll introduce today's seminar speaker in a second, hear from Dr. Jen Santoro about Good Things Come in Trees, the benefits of a neighborhood canopy, and Dr. Adam Langley, the carbon balance of forest growth and destruction. And so, I think, again, each of these seminars is highlighting various portions of the biodiversity. And it's really cool, and what we'll hear about tonight is Dr. Shakya's seminar is going to be especially interesting because he studies environmental justice, environmental health, and he does this through the lens of pollution, both indoors and outdoors. And in reading, again, my colleague, Dr. Shakya's CV, I was really struck by how truly interdisciplinary he is as a scientist. And so he studies air pollution and everything from soils and community gardens, and we were just talking about some of the field work that he's been doing on that this summer, up to air quality in subways in the Philadelphia region, and really then looking at a broader scale with some of the other colleagues at Villanova, both in the geography and the environment department, but also and other colleagues across the institution, including at the College of Nursing, thinking about environmental health all over the city. And particularly with respect to how does air quality around the city of Philadelphia vary? And so we're really lucky, to have him at Villanova and to have him as part of this seminar series of biodiversity in our neighborhood, because he'll be sort of looking at this through the lens of, how does biodiversity, and in particular, plants and canopies and things like that, sort of help us with some of the environmental problems that we have through air pollution in our area. And so I'll just give you a little bit of an introduction on Dr. Shakya. So he did his undergraduate degree in Nepal before going to his second master's degree, actually, at Chiang Mai University in Thailand, and then went to Rice University for his PhD. And from there, he did postdocs at UMass and University of California at San Diego before coming to Villanova and becoming a professor in the geography and the environment department. So Dr. Shakya has grant funding from the National Institutes of Health as well as the National Science Foundation. And so in scientist speak, that kind of means he can do all the things, right? He can think about things from the human health perspective, but he can also think about empirical science to be funded from the National Science Foundation and applied science as well. And so he's published over 30 papers. And again, the cool thing about looking at his work and his body of work is that he is working with so many different people within the region of Philadelphia and within Villanova. And so again, we're grateful to our Grow Oakwell partners in this seminar series and coming up with this idea. And with that, I will stop sharing my screen and I will let Dr. Shakya have the mic.
Sorry, I was trying to grab the Zoom screen. You can see my screen, right? Okay.
Yep, Cobbin, you're good. We can see it.
So thank you so much for the nice introduction about me. So I will again introduce myself. My name is Shakya. I'm an associate professor and environment science program director at the Department of Geography and Environment. And today, rather than going into depth in talking about intricate chemical variation and others, I would just give the overview of how the air pollution vary across the Philadelphia and the region based on the few limited studies that I have been doing with the help of the colleague in collaboration with the different professors and the students at Geography and Environment Department at Villanova University. So first of all, I would just like to introduce us briefly about different air pollutants, because I know we have the a wide variety of audience from outside of Villanova as well. Among that, also, my focus is mainly on the particulate matter. So I will just talk briefly about that. And then I will present a few studies which I would separate based on the mobile monitoring and the stationary monitoring. And I would briefly mention later on what do I mean by that. And finally, I understand we are trying to do it to benefit the Oakwell community. And I have done some literature review on why the urban vegetation matters to us. And so I'll conclude by that at the end. So this may be a lot of repetitions for some of you, but I'll just briefly go over this for the air pollutants. So when we say the air pollutants, we usually mean air. We think it's mostly the gas. So that's actually true. So most of the pollutants are the gases, such as sulfur dioxide, carbon dioxide, carbon monoxide, nitrogen oxides, hydrogen sulfide, and hydrocarbons. These are the most important gaseous pollutants. But there is also another kind of the pollutant, which is not in a gaseous form, and which could be the one of the main concern when we talk about air pollution. If we actually look at any news that we see about the air pollution, most of the times they would be talking about the particulate matter. And what we mean by the particulate matters is these are the liquid or solid particles that are suspended in air. And these are usually given the acronym PM, and which stands for the particulate matter, and given the number 2.5 and PM10. And I'll talk about in the next slide about that. And finally, there is also the last category that is given by the Environment Protection Agency, which is known as the hazardous air pollutants, also given the name air toxics. Means these are the ones that are the most harmful for us, most hazardous to us, because even at the very low concentration, that can cause the cancer and the serious health effects, reproductive effects, birth effects, and other different kinds of the environmental effects. And some of the examples these are given. So I have taken that from the website of the US EPA website. And so these could be like benzene in gasoline, like perchloroethylene, methylene chloride, toluene, dioxin. So these are just few of the names from the 188 compounds that they list as the hazardous air pollutants in the EPA's website. So again, I'd be focusing mainly on the particulate pollutants. So these are the what we call as the US EPA's regulated criteria air pollutants. So there are like hundreds or maybe even like thousands of air pollutants, but out of that, there are only the 6 pollutants for which we say we have set the safe standards. So we have given the standard for these 6 pollutants, and the labels means these are the values that it should not exceed in our community. And when we say that, it doesn't meet, there is a pollution or it doesn't meet the standard. So these are the things when EPA is monitoring the air pollution, and when it exceeds these numbers, then they call it as a non-attainment zone, means that these community or the city doesn't meet the standard. For example, for PM 2.5, the standard is 1 year average, it should not exceed more than 12 microgram per cubic meter. And for 24-hour average, it should not meet 35 microgram per cubic meter. So what we mean by the particulate matter is the PM 2.5 means PM stands for the particulate matter. And usually the standards that we saw earlier, that is given for the mass concentration. So how much of the mass it is there. And so the PM stands for the particulate matter mass. And 2.5 means these are the diameter of the particles. So when we say 2.5, so as you can see here in the human hair are like about 50 micrometer in diameter, whereas the beach sand is about 90 micrometers. So both of them we can see by our eyes. But when we look at the PM10, so that is about 1/5. Larger stuff. Again, PM10 doesn't mean just one size. It's of all the particles that are smaller than 10 micrometer in size. So that could be dust, pollen, or mold. And then PM 2.5 is even like less than 1/4 of the PM10. So any particles that are smaller than 2.5 micrometer. So we are now talking about the very small particles that which you cannot see by our eyes. So these PM 2.5 particles are the ones that are emitted from the combustion. This could be the metals. This could be made of various organic compounds as well. And unlike the gas compounds, which have the definite chemical composition, for particulate matter, their chemical composition varies a lot. So overall, these could be made of carbon compounds, different organic compounds, metals, different ions, and it could also be contributed by the microorganisms in the air. So the main concern for us for the air pollution is its health effects. It also has the short-term health effects and the long-term health effects. So this is the slide that I took it from the Public Health England's website, where it says that the short-term exposure to the pollutants that can cause like asthma, initiation of the asthma, or the worsening of the asthma, or the other symptoms. And then the long-term effects can even be a stroke, lung cancer, various respiratory diseases, and cardiovascular diseases, and even can reduce our life expectancy. And we may not know that, but a lot of actually the cardiovascular diseases, for example, 34% of the deaths from the stroke, 27% of the heart diseases, these are estimated to be due to the air pollution. And we all know about the lung cancer. So 36% of the deaths from the lung cancer is estimated from the exposure to air pollution. So overall in the world, it is estimated overall about 7 million premature deaths are estimated to occur due to the exposure to air pollution. And the estimates vary, but the World Health Organization estimates about 7 million premature deaths due to air pollution. So this is every year we are talking about. Air pollution has various health effects, but the health effects are not the same for everyone. For example, the older people, children, pregnant women, and the people like communities of the color or the people who live closer to the highways, these are the ones that are most vulnerable to the air pollution. And these are the ones that are going to be most affected from the air pollution. And air pollution is also an environmental justice issue. So it is estimated that people of the color, they are living in the region with a higher amount of the air pollution. For example, this infographic says that 38% of the people of color have about 38% higher nitrogen dioxide exposure than the other population. So with that brief introduction, I would move on to a few studies that I have conducted since I started at Villanova University. So I'll briefly go over the 3 studies, which I would name it as the mobile monitoring studies. So I'll talk briefly about what I mean by the mobile monitoring study. So I'll go over the 3 different studies, and even though we didn't plan it, but it actually happened that we seem to be doing some studies every 2 years in a pattern. So we started with the summer 2017 with the faculty summer grant, and then we received the National Science Foundation grant, and we continued on summer 2019 and summer 2021. So the first study about the 5 neighborhood study that we conducted in summer 2017. So in the summer of 2017, from June 5th to July 7th, we actually put in a backpack and we hired 3 undergrad students, and we used the portable instrument which can measure the noise, PM 2.5, and the black carbon. And then we walked for about 5 kilometers in the 5 different neighborhoods. And we walked over, I believe, like 60 times in the different period, in morning, mid-afternoon, and late afternoon. One of the reasons that we want to assess these air pollution in the different neighborhoods is that we also want to see if there is environmental justice issue. As you can see here in this table, some neighborhoods have high population of the minorities. For example, in the Tioga and Mill Creek is mostly non-white and also has a high poverty. And also we want to see the land use as well. For example, like the tree cover and other roads, and how does it vary? Even though I won't go into detail into the relationship with the land cover, I would just briefly present how does the air pollution level vary in this talk. If you're interested, you can email me, or you may be able to find this paper, which has already been published, and you can find the details in this one. So these are the paths that we walked. In this case, we actually walked in the first left-hand side. You can see the small maps. These are the 5 different neighborhoods that we walked in the Philadelphia city. And then the other 4 maps, that's 5 maps that shows our path that we walked. And the last figure shows how the air pollution level varied among 5 different neighborhoods. And overall, you can see from this figure alone that Chestnut Hill, for some reason, had the highest amount of the PM 2.5 level than the other neighborhoods. So overall, we can see that in the case of the PM 2.5, Chestnut Hill had the highest amount of the PM 2.5 compared to the other region. And we also put the dashed line to compare with our standards. Overall, air pollution, at least in the summer for PM 2.5, it may not exceed the EPA standard, although EPA standard is based on 24-hour average and 1-year average. Our study is just based on like 2-hour average. So we just walked in 2 hours. We didn't put the instrument to measure it for long term. So it's not directly comparable, but still we can put some reference to see that whether our levels, it should be of concern or not. So it should not, it doesn't look like it's of the great concern for the PM 2.5, but again, it looks like for all the times in Chestnut Hill had the highest level of the PM 2.5 compared to the other location. And when we talk about the black carbon, so black carbon as the smoke, so the black smoke that we see, and that smoke only are formed, black carbon is only formed when there is something that is burned. So it is not formed. So particulate matter, one of the things is that these are not emitted only from the combustion or from some emission sources. Particulate matter can be formed in the atmosphere from the chemical reaction of the gas. So something may be emitted as a gas, but they actually may react in the air and can form the particles. But the black carbon is formed only from the emission when something is burned. So in the city, when we see the black carbon, this indicates that there might be a traffic emission source. So the Northern Liberties, when we looked at the map, it was located closer to the highways. So it makes sense in that it was highest black carbon level that we observed in this neighborhood, and especially in the morning. And that is perhaps we assume due to the lot of traffic that is going on during the commuting time in the morning. And noise is the one that could be of concern, and it may be also because we are walking down the pedestrian pathway, and it was a little bit higher maybe compared to the other location, but noise could be of concern than the air pollution in these neighborhoods. So this is the main conclusion that we found, although in a paper you can see the other analysis that we conducted on the study as well. So the second study that we moved on is in the city of Philadelphia. So in the earlier one we did by walking, So if you want to actually expand our study to the entire city of Philadelphia, it won't be possible to walk and all the paths of Philadelphia. So what we did in this case is that we put on our instruments on the roof of the van, and then we drove around the van. As you can see here, we drove for like 300 miles of the distance, and it was not possible to drive around 300 miles in one day. So we divided into 2 different days. So route 1, as you can see in the legend with the blue color, is the one that we conducted one day, which is 150 miles, and another day, then we go to another route, which is given by the red color, another 150 miles. So we try to cover as much of the Philadelphia city as possible in this study. And in this one, we tried to create the air quality map. And again, this was done in collaboration with Dr. Pelle Kramer, who helped to make the map, who is designed, because she has the expertise in the land use classification. So we wanted to cover as much of the land use classes as possible so that we can see the relationship with the land use classes as well. Although I'm not talking about the association with these in my talk today, I will just talk about the labels that we found. And these are the labels from the 12 different days that we did. Overall, again, the PM 2.5 labels that vary across the different days, but again, it doesn't seem to be of main concern considered to the EPA standard, at least for the 24 standards, which is 35 microgram per meter. Our all levels were below that. Again, although our measurement was not even for the 24 hours. We did about less than 10 hours when we drove for this study. And then we created a map. So the first map that I showed is the ratio of the black carbon to PM 2.5. The reason that we wanted to do is that when we see the relationship between the black carbon and the PM 2.5, that means that it's associated with perhaps the traffic sources, the combustion that is happening from the cars. So that might be the main source. And it contributed about 11% of the PM 2.5 was contributed only by BC. BC's black carbon is again not separate from the PM 2.5. PM particulate matter. Particles are made of very many different components, and black carbon is one of the component. So black carbon alone in this case contributed about 11% in this case. And then we try to see where the black carbon contribution is the greater. So we found that in the North Delaware Planning District, NDEL, in the top portion, top right-hand side is the one. And we assume that is due to the heavy traffic conditions, industries, and the major roads might be the one that is contributing the higher contribution of the black carbon to PM 2.5. Also, we found greater in the airport region. The reason that it is also important is that although PM 2.5 levels might be below the EPA standard, but what is PM made up of matters a lot in terms of understanding how much it actually affects our health. If, for example, if the PM, even though it may be lower than the EPA standard, but if it is contributed mainly by the black carbon, then it could be of a great concern, even though PM is below the EPA standard, because black carbon is the one that can be of carcinogen. So it's considered as one of the can be potential carcinogen, and so it can have a lot of other adverse health effects. And this is another air quality map that we made for the PM 2.5. So we created this hotspot in the Philadelphia region, and we found that hotspot areas are the one that has the highly trafficked regions. And we also found the lower hotspot region outside the urban core. Again, might be related with the vehicles and the traffic, although we didn't assess the relationship with the traffic in the study. Again, we have published 2 different papers just based on this study. If you're interested to learn more about this, you can read in this study. We have done more in-depth studies to understand about the air quality in these 2 papers. And the last study we conducted, again by the mobile monitoring study, is now we did in a different neighborhood, we did in the entire city of Philadelphia. Now let's try to see that how does outside of Philadelphia, because most of the air pollution, when we think of it, we think of mainly of the cities. Okay, cities are the one that is just the main concern for air pollution. If we live in maybe suburban and semi-rural, there is not enough data. There is not much study that are conducted. So we wanted to see outside the major city, like how does the air pollution level vary? So then we actually, in this case, drove around the Lancaster Avenue. Again, we put the instruments and the top of the van, and then we drove around the Lancaster Avenue. So we have been expanding the study since then. In this case, we didn't focus only on the particulate matter. So we, and black carbon, we also measured the gases such as nitrogen oxides and ozone. And it took about 4 hours to drive for about 65 kilometers that we drove from the city of Philadelphia all the way beyond Downingtown. And we drove in the morning time and the afternoon time to see that how the air pollution levels vary in the morning and afternoon time and the different regions like urban, suburban, and the rural region. And we did total of 20 replications, 10 in the morning and the 10 in the afternoon to get more representative data of this Lancaster Avenue. So this is the path that we drove. On the right-hand side, you can see the Philadelphia, and we reached all the close to the Coatesville. And so this covered a lot of townships, city of Philadelphia, and overall the distance was about 65 kilometers. So here I'm just briefly showing overall the pollutant level in the morning and the afternoon. In overall PM 2.5, it doesn't seem to vary overall in the morning and afternoon, but we see that a lot of high values was observed in the morning time compared to the afternoon time. What we see the difference is the black carbon, because black carbon levels were higher in the morning. Obviously, maybe there was more traffic because of the commuting time. So we observed more black carbon during the morning time, and which is also indicated by the NOx level. So a lot of high values in the NOx, again, we observed in the morning time. And ozone is the one which observed in the afternoon was much higher than morning time. And we know it's because for ozone to be formed, it is based on the sunlight. Sunlight is required. Ozone is one of the pollutant. I talked earlier about forming from the emission. Ozone is never emitted. So means that ozone, it is formed from the chemical reaction in the atmosphere. Ozone is never coming from any gas pipe or anything. There is the nitrogen oxides and the volatile organic compounds, these reacts, and it needs the sunlight to form. So as the sunlight intensity becomes more in the afternoon, and also it becomes higher temperature, so ozone is higher in the afternoon. And one other thing that we also want to do is that instead of like categorizing, it was hard to categorize which one we consider as urban or which one we consider as rural. So what we did in this case is that we looked at the population density of these regions. So we made the buffer, and then we try to see, okay, which ones are the one that has a high population density, which ones are the low population density, and which ones are the medium. And so we looked at the pollution levels in different regions. As you can see that high population density are located mostly towards the right-hand side, which is closer to the Philadelphia city. And then we have the yellow one, which is mixed, but almost like in between, except closer to the Downingtown, which is, I hesitate to say as a suburban, but that's what actually we're trying to see it as. And low is the one that has like low population density. And we wanted to see that how does air pollution level vary outside or closer to the major cities such as Philadelphia. And this we are seeing the PM 2.5 levels in the morning and afternoon in these three different categories. Overall, what is interesting is that it doesn't seem to be like PM 2.5 levels vary greatly in the high or low. And surprisingly, actually, the medium population density has even lower PM 2.5 than the other region, high and the low. And same thing, we looked at the nitrogen oxides. What is interesting is that low population density region has the lower NOx, and the NOx is the one that is of indication of from the car. One of the main source in the city for the nitrogen dioxides are from our cars. So it looks like in the high population density, NOx are higher, but in the medium population density also we found the high NOx levels. So we cannot assume that just because we are farther from the city, or the pollution levels is going to be, as we go closer to the city, pollution levels might be the highest there. And the ozone is the one that did not seem to vary much among the three different regions. Again, this is formed mainly from the secondary reactions, so we didn't see any variation in the three different regions. So this is manuscript still in preparation. So this is the last portion of our grant, and we're still working on making this manuscript. So all this mobile monitoring that I mentioned is by mobile. So we didn't put the monitor around there. For example, when we hear about the air pollution from the EPA, they actually make the trailer and they put their station there, and it's always stationary. But in our mobile monitoring studies, either we're walking along the path or we're driving to measure the air pollution. So the last portion of my study, I want to talk about the stationary monitoring study. So in the stationary monitoring study, we measured mostly in the earlier studies, I focused mainly in the particulate matter. But in this study, we measured the air pollution of the different gases. So we measured the nitrogen oxides, ozone, ammonia, and sulfur dioxide. And this was the master's thesis of a graduate student at GB, Brian Terry. So he is the one who did all the work in this. So we had what we call as a passive sampler. You see here in the picture. So we put the passive sampler in the pole in some cases. In this case, he put it in the wall, his stick. And we had a total of like about 15 sites. So in the city of Philadelphia, an urban location, which we call as a green color, we had our 7 sites, suburban locations in Norristown, like KOP in different locations. We had a total of 6 sites. And semi-rural, which is in the farther side, as you can see in Downingtown and Skookenville, is the one we have 2 sites. And we also went to the EPA monitoring site, and we put our passive sampler at that location to check how much, to check mainly for the quality control and quality assurance, to compare our study with that. And we monitored this in the 3 different seasons. This is not a mobile monitoring study, so we put this passive sampler in that location for 1 week. And then we go on to collect that passive sampler and then again put. So we measured in the 3 different seasons. In each season, we measured for the 2 weeks. So in the case of the ammonia and the background and suburban and rural locations, overall, we see that winter is the one that has the highest amount of the ammonia for some reason. And then in the case of the 3 different sampling site, we see that background location had the higher level of the ammonia and the highest in the winter season. In the case of the ozone, we see the highest again in the spring. It's because the spring is the one that has the highest temperature. Ozone is highly dependent on the temperature. And what is also interesting is that the spring, that is the one that has highest level of the ozone, there is no difference in the ozone and even 3 different neighborhoods, which is quite interesting to see. There is not variation of the ozone in the different neighborhoods, in different sampling sites, either background, urban, or suburban locations. And nitrogen oxides, which is the one that is formed mainly, we assume is from the cars. And that's the one we assume it to be higher in the urban location, and which is actually in all the 3 seasons overall, except in the fall and winter and spring, we found the urban locations had the highest amount of the nitrogen oxides, and that is due to the highest number of the cars, higher traffics, and that's the region that we see higher amount of the nitrogen oxides in the cities. And these are the this is the graph that is showing in each of these urban or suburban or semi-rural site, we had a different site. So in the semi-rural, we had 2 different sites. So Skookenville is the one, even though we consider that a rural, one site actually had much higher level of nitrogen oxides than the other. And overall, we can see that urban sites, the sampling sites that we consider urban, had overall higher level of the nitrogen dioxides than the other locations. And even among the suburban locations, we see the variation of the nitrogen oxides And then we did another graphic visualization to see what is the ratio of the nitrogen dioxide to the nitrogen oxides. So when the ratio of the nitrogen dioxide to nitrogen oxides are that are equal to NO2 plus NO. So we are just looking at how much of NO2 is contributing to NOx. And here we are seeing, when we see the higher amount of this, that indicates that it is formed more from the traffic emission sources. So we see that higher amount of this contribution more in the urban location as compared to the suburban locations and the urban locations. So another study that we have been working under this manuscript, it's currently in review, is that EPA has been monitoring the air pollution in Philadelphia starting from 1986. So this data is publicly available in the EPA's website, and we wanted to see that how the PM level, how the air quality has been changing in the city of Philadelphia. And actually, you can just look at the Philadelphia's website. You can see clearly, just based on these two websites, that we can predict that air quality has got much, much better compared to the earlier days. So PM levels, that means, had also been declining. So our air quality is improving. And this is the work that is done by 2 undergrad students at GEB, Haley Carino and Sydney Walsh, who are still at GEB. And in this one, we see that PM10 compared to 1986, 2021, it has decreased by about 47%, and PM2.5 decreased by 31%, and it is on a continuous decline. So that I want to share as a good news that we are doing good, and we also are looking at this study to see how much of this is contributed by the introduction of the various environmental policies. So we have compiled the various level of the environment policy and how much it may have contributed to this success of improving the air quality. So finally, I want to acknowledge National Science Foundation, and this was actually started by the Villanova University's faculty summer grant in together with Dr. Pelle Kramer at GEV, and we had several graduate students, undergraduate students, and we had a strong support from GEV, and I greatly acknowledge I'm very grateful for all for this study. And finally, I know that the main reason that we are running this series is because of the Oakwell community, and we are sad to hear about what's going in Stoneway. And I did briefly some literature review to understand what is the benefit of urban vegetation. So when you have urban vegetation, such as in a some urban park, a lot of trees, that helps to actually capture the particulate matter, and that leads to a decline of the particulate matter. That helps to filter the pollution, and that actually helps to reduce the particulate matter in these locations. It may not be 100% guaranteed that when we plant the trees that air quality is definitely going to be better. In some location, it may not be a case. And also it depends on the meteorology, like the wind, tree species. And in some study that this benefits air quality decline was actually insignificant with the amount of the vegetation. I just also want to mention, but overall, actually vegetation might lead to decline in PM in several studies they have found. So it can capture the vegetation. And besides that, there is a lot of studies that actually show that increased risk for stroke and myocardial infarction, that we see one of the cardiovascular effects due to the exposure to the PM that was found to be chronic exposure to the course. So higher exposure to the PM means high incidence of these actually was found to decrease when there was high amount of the greenness in the neighborhood, again indicating the benefit of this urban vegetation around in our neighborhood. And in this one, that is showing that when we have the foliage like that, even though our house might be closer to the road or the highways, if we have this row of the foliage or the trees, that actually leads to a lower amount of the various particles, in this case, a UFP, which stands for the very small number of the size of the particle, which stands for ultrafine particle, which is actually PM.1. We have been talking about 2.5 and 10. This is actually even much smaller size of the particles, which can even cause can have much adverse health effects. And ecosystem benefits, there are also other benefits besides the air pollution. This actually helps to reduce the ambient temperature. As you can see, during our summer, it can help to reduce the AC running. It helps to reduce the noise. It helps to reduce the stormwater runoff. It's great for the aesthetics, as we know, for physical exercise, the nature, the biodiversity. It also helps to improve the physical and mental health, and it's been especially been more significant for children, elderly population, and population that are with the limited mobility, and also economy as well. It helps to reduce the energy as it reduces the temperature. We don't need to run that much of the AC. It helps to reduce the medical cost if we don't get sick. If we are happy, then it also improve our worker productivity, increases, and we also like the greenery, so it also increases the property values as well. So I finally like to, this is my last slide, conclude with this two quote that I found in this paper. It says, vegetation is essential to achieving the quality of light that creates a great city, and that makes it possible for people to live a reasonable life within an urban environment. And this one was quite interesting, so I just quoted again. Patients with rooms facing a park had 10% faster recovery and needed a 50% less strong pain relieving medication compared to patients in rooms facing a building wall. So this shows that how much important the green vegetation plays in our life. So thank you so much for attending. This is my last slide.
Thank you so much, Dr. Shakya. That was fascinating. I think, using your really elegant and high-tech methods to show, how important roadways are for the air that we're breathing, and show how the density of our cities can change things, and also to give us some hope with how much environmental regulations have done for changing our air quality in the Philadelphia region already, and hopefully how much more we could do by preserving forest fragments and planting buffers, et cetera. So if possible, we already have some questions in the chat. I would ask people to put questions that they have for Dr. Shakya in the chat, and I'll moderate that. And if we do it like that, it's easier for us to post this on the YouTube channel for this CBEST growing our biodiversity in our neighborhood seminar series, which has already been getting a bunch of views. So thank you for putting your questions in the chat. And I'll read them out to you, Kaban, if that's okay.
Yeah, sure.
So the first question is, could you comment on the PM 2.5 this summer from the Canadian wildfires? And sort of, obviously you were in the news and other things about that. So can you talk a little bit about that, the PM 2.5 that was coming into our area from the wildfires?
I thought about for a while to show that graph and just to talk about that. Fortunately, since I was doing a survey study, we were actually able to capture. I put in a roof of the Villanova, one of the building, and Bartley building, and then we saw. So we saw the PM 2.5 increase a lot, I would say. So it was showing before the wildfire came about 8 or 10. It was measuring, and then on that Wednesday, when we see everything is doomed, right? Blue color, it reads as high as 800.
Wow. That's
so
amazing.
that is unheard of. I had never seen that high level before. So actually I'm presenting that in AGU this fall, just based on wildfire. So that was very, very bad. That was nothing that I had ever seen.
Yeah, absolutely. That's incredible. It's really great to have these monitoring equipment, right here in our neighborhood at Villanova for these kinds of things. So that's awesome. So another question, how about pesticides and herbicides such as glyphosate and Roundup? One of the major sources of airborne particulate matter are leaf blowers, which are used to blow dust around. So what are your thoughts on, some of those herbicides and pesticides and sort of how they're moved around versus with lawn equipment?
So pesticides is one of the things that is itself can create. I mentioned that there's a lot of air pollutants, right? Pesticides can be a pollutant as well, because if they linger in the air, right, when we're spreading it, and then that can be a source of the air pollution as well. And coming to about the leaf blowers blowing, I think rather than the resuspension of the dust, my concern is actually the combustion that is coming from the leaf blowers itself. Because even though in Villanova, sometime, when you walk, we can actually feel the smell that is coming from a combustion, right? It's actually really a nauseating feeling that comes. That is of the more concern than the dust, because dust is the larger particles that when resuspend, that doesn't stay longer. That again has to settle it and it fall down. So that is much temporary compared to the other one that we're running it by this gas combustion. In my personal opinion, gas combustion is of the more concern than the resuspension of the dust.
So you're saying the gas combustion creates smaller particles that stay suspended in the air and therefore
Longer.
more likely to breathe in than the,
Yes.
the dust particles, which are larger and therefore fall faster. Okay, that's really interesting.
Yeah.
So yeah, there was another response to that. Excellent question, Tim. Dr. S, do you have any information to share about the air quality in places like DC where blowers and gas-powered land equipment has been banned?
So I didn't know. Thank you for letting me know. That's really good. And I have seen about blower and gas more that can create, as I mentioned earlier, right? I think the combustion, if we have like every neighborhood that is again running the gas blower all the time, that could be of a more concern. I think that's really great news that they have banned the gas, and I think we should see the improvement in air quality based on that. I don't know whether it should be significant or not, but it should lead to some decline in particulate matter and other gas.
Noise pollution too, for sure, right? And
Yes,
I think California has also banned gas lawn equipment, if I'm not mistaken. So another question, are you familiar with the Purple Air Monitoring Program?
Yeah, I actually have one Purple Air, and there is also the other monitoring program. Yeah, Purple Air is one of the things that it just costs very less, like about $250 to buy. And then if you actually put it in our backyard, it actually goes live. So anyone in the world can look at what's the air quality in that neighborhood and can download the data in that. There might be some concern about calibration and checking, but that's really great. And there is also other like, TSI. There is also now the other programs that also have popped up. They are doing the similar thing as well.
Cool. That's great. Yeah. And someone posted a link in the chat, I think, about this quiet, clean Philly thing about potentially about the lawn equipment. So I have a question for you, Kevin. So you mentioned about how vegetation can effectively bind up particulate matter, I think almost irreversibly, right? And so that can sort of, my understanding of this is that the particulate matter can get bound up into the leaves of trees and essentially is bound by the waxes to some extent. But you mentioned that different species do this differently. Can you talk a little bit more about that with your reading of that, which is, obviously this could be very impactful for deciding, how do we plant green buffers, or how do we maintain a more healthier environment on campus, along Lancaster Avenue or in the broader mainline area as a whole?
So this is one of the areas that I haven't done the study, but to create this literature review for urban vegetation, there is a lot of study. They have put in a different tree species, and they have looked at how different tree species actually can capture. And they mentioned that rather than grassland and shrub, trees are more helpful. And also it depends on which one is the one that has a more leaf surface area. So higher the surface area, more potential for the capture. And the other thing that I remember from that reading the literature is that they were talking coniferous plants are actually more efficient in capturing the air pollution. And one of the reasons they say that perhaps because, in the falls, the leaves don't fall, right, that much. So the pine needles, and you talked about like brushy stuff like the hair, that helps to capture that texture. So there is a lot of actually literature that has looked at that. And I think EPA also has a report that recommends what kind of the tree species are beneficial if we're actually planting along the roadside. So there is a lot of actually study that's done and recommendation as well in the reports. That's
really cool. So just to follow up on that, and please, anyone else that has questions, feel free to put them in the chat. But that just reminds me, I've been a little bit involved through our efforts with the flower show with the Horticultural Society, and I know the dean has been involved as well. who's on this call with the Horticultural Society. And, their goal is to help with this 30% canopy in the city of Philadelphia. And I know through your and Dr. Kremer's work too, this greening of the city. So do you think that those efforts in increasing urban canopies in Philadelphia and surrounding areas, are they targeting sort of roadside areas for the reasons that you describe in your work, that, the more buffers you have along the road, the more air quality improvements you're likely to see in terms of that ecosystem service?
I am not actually familiar, but actually, if you're interested, we have actually great colloquium speaker. This time I'm actually organizing, and I have invited one from Department of Agriculture, Miss El Kondo, and I listened to her talk in one of the conference, and that I invited. She has been helping to convert some of the abandoned lots into the greenery. Definitely, I think there might be, a lot of different motivations for that. One of them might be the cooling, right? Like the mental health, the physical health. Some of them actually have converted into community gardens as well, right? So they can get other benefits. And definitely that may help to improve the air quality as well. But air quality is kind of interesting because just having the trees planting, it's not guaranteed that it's gonna create the reduction in air quality. We should always, what they call it's in the textbook of indoor air pollution, is that if there is let's say the pile of like cow dung in the room, right? Instead of trying to see how to get rid of that odor, right, different ways, we should get rid of the source, right, first. So all other things are helpful, right? But that cannot minimize what is the main source in the city, which can be the industries or cars, right? If we that should be the one that we should be targeting first, right, not other things. So
the point source pollution. Yeah, absolutely.
Yeah.
Yeah. There's a couple other things in the chat about how these 2-cycle gas motors are worse because they require the oil mixed with the gasoline. And then another point about how they've now banned gas-powered leaf blowers in New York and Virginia and other places, and it'd be excellent for more studies to show the benefits of banning these things. And so, is this something that you've considered thinking about, gas lawn equipment and things like this with air quality? I guess it would be challenging, right, to get an integrated measure of that but I guess with your stationary measurements, you could do something like that.
There is already, I believe there should be like emission factor that do like how much from the gasoline engine, how much of the pollution that is emitted versus that how much it is coming from the other kind of things. In the engineering, some courses that I have taken, you can actually back calculate how much of the emissions. So that's
cool.
Yeah,
very cool.
Yeah,
awesome.
That's true. Gas engines that are mixed, or the 2 strokes, that might be actually worse.
Very interesting. So one other question: mosquito-borne illnesses and Lyme disease increase with the loss of woodland habitat, right? I'm not sure if this is part of your work. Jen?
I'm not that much.
I don't know. Jen, do you want to weigh in on this? Do you know anything? So Dr. Santoro has worked in New England with forests, or Dr. Weeder or somebody else want to weigh in on this? I have seen some of these links about Lyme disease and different forest canopy, but I think I would have to look at the literature if anyone else wants to chime in on that.
I would have to dive a little deeper too. I don't know much about insect-borne human diseases.
Okay, yeah, maybe this is something we could look into for one of our. Yeah, go ahead.
I think I see someone else from our department, Dr. Legiardo, who is an infectious disease doctor.
Thank you, Cobbin. Yes, I am here, and Lyme disease is amazingly complicated. So, if you have deer, that's going to amplify the blood meal for the ticks. If you have small animals, they're going to provide blood, and also they're going to provide a way for the ticks to reproduce. And so actually, Sam, the literature is both ways. So if you alter the ecosystem either way, and you increase the elements of the life cycle, then you will have more Lyme disease. The biggest thing, however, is going to be human exposure to the ticks, and that's going to increase Lyme disease. But no question, Lyme disease is increasing around the country. Just, an example of, from where I grew up on Staten Island, there was no Lyme disease. And then the deer figured out how to cross the small bodies of water between Staten Island and New Jersey. And now there's lots of Lyme disease because of the blood meal that the deer provided for the ticks. So Lyme disease is complicated, but you have to look at all the elements. And if you remove any of the elements, then you're going to have less Lyme disease. If you increase any of the elements, whether it's a deer or ticks or small animals, then you're going to increase Lyme disease. But for sure, the best way to avoid it is for humans not to be exposed to ticks.
Right. Thank you. That's so helpful. Thanks. Awesome. So the question then, one last question, is, but if we increase trees, et cetera, won't more possum and opossums eat more ticks? Will there be more tick predation, I guess, is one idea. I don't know. That's a good question. How to actually control the ticks. Yeah, I mean, I know, many parks in our area, some of people who have been on these calls, who are managers in those parks, are certainly having targeted reduction of tick exposure by human by, controlling deer populations and things like that. And that seems like a good public health campaign for sure. So I just want to thank Dr. Shakya. This has really been fascinating and wide ranging, and in terms of our interests about thinking about our environmental health and justice in our region. And so I'm very excited to sort of see where this goes from here, right? Because all of these threads seem to be weaving together across thinking about organisms and how humans are interacting with them in our very own area. And I do think there's a lot of hope in this area to improve, right? As we've seen in air quality in the Philadelphia region from Dr. Shakya, and his work will definitely continue to push us in that direction. So thank you so much for all of you for coming and sharing this conversation with us. And thanks so much, Dr. Shakya, for this great presentation. We appreciate it.
Thank you so much for the opportunity. Thank you.